Hello everyone. Today we're going to look at the law of sines. So if we have a triangle and we know three pieces of information, legs or sides, then we can find the other three. And this is assuming that we don't just know the three angles. So as long as we know at least one side and then two other pieces of information, we can find the rest. This process is known as solving the triangle. There are 4 different cases to consider. We can be given 2 angles and a side, two sides and the angle between them, or given 3 sides. These 4 different cases are going to have to be considered separately. We're going to look at cases 1 or 2 first. So these cases can be solved using what's called the law of sines. So if we have a triangle, we label the angles with the capital letters A, B, and C, and then we label the sides that are opposite them with the lowercase letters. So for instance, the side opposite angle A is lowercase a. The side opposite angle B is lowercase b, and the side opposite angle C is lowercase c. The law of sines states the following. If I look at the ratio of a leg to the sine of the angle opposite it, that ratio will be equal no matter which side and angle we're looking at. So A over sine of A equals B over sine of B equals C over sine of C. I can also take the reciprocal of each of them. So it depends on what I'm looking for. If I'm looking for an angle, then I want to use these guys. And if I'm looking for a side, I want to use these ones. So whichever one I'm looking for, that's the one I want on top, because those ratios are easier to solve that way. So we're going to look at case 1 first, which is when we're given 2 angles and a side. So given that angle A is 60 degrees, angle B is 40 degrees, and side C is 6, we want to solve the triangle. So here's a picture of what it looks like. You might want to write this down because I'm not going to show the picture again when we do the math. So if you want to pause it right now to write it down, feel free to. So we're going to first begin by finding the third angle. And we know that if I add up the sum of the angles of a triangle, I always get 180 degrees. So if I want to find angle C, I just take 180 degrees and subtract the other angles. So I get that C is 80. Next, we're going to choose a side to find. Doesn't matter which one, so let's do A. So we use A over sine of A equals C over sine of C, and of course there should be a parenthesis there. And we know C, and we know side C, and we know angle C, so we plug those in. If I want to get A by itself, I just multiply by the denominator. So A equals 6 times sine of 60 divided by sine of 80. Plug that into my calculator, I get 5.28. We're going to do the same thing for side B. We're going to set up that B over sine of B equals C over sine of C. Again, I know angle B, I know angle C, I know side C. And again, I just multiply by sine of 40 on both sides to get B by itself. And when I plug it into the calculator, I get 3.92. So I've now found the 3 different things that I wanted. Angle C, side A, and side B. So next we're going to do another one where angle A is 56.29 degrees, angle B is 97.06 degrees, and side A is 63.71. And again, here is a picture of the triangle if you want to copy it down so that you can see what we're doing as we go along. And again, we're going to find the remaining angle first. C equals 180 degrees minus 97.06 degrees minus 56.29 degrees, and that equals 26.65 degrees. Next, we're going to find a side, and I just tend to do it alphabetically, so we're going to find side B first. So we have B over sine of angle B equals 63.71 over sine of 56.29. So A over sine of angle A. B is then the right-hand side multiplied by our denominator on the left. Plugging that into the calculator, we get 76.01 degrees. Not degrees, it's not an angle. 76.01. And then lastly, we're going to find remaining side C. So we've got C over sine of C equals, again, A over sine of A. Then I get that C is the following when I multiply both sides by the denominator. And I get 34.35. One thing that I can do, if you remember from Tech 1, to check to make sure that my answers make sense, is to remember that the larger side is opposite the larger angle. So we had that angle B was the largest, and we've shown that side B is also the largest. We also had that angle C was the smallest, and we now have that side C is the smallest. So you can always check to make sure that your answer at least seems reasonable. Now we're going to look at case 2, which is two sides and an angle opposite one of them. In this situation and in this situation only, we could have 0, 1, or 2 solutions. Cases 1, 3, and 4, there's exactly one solution. But case 2 is the special one. We could have no triangles, we could have one triangle, or we could have two triangles. So we're going to go through the process and see when it's 0, 1, or 2. So here's our first case. We have that angle A is 35 degrees, side A is 10, and side B is 12. We want to solve the triangle. So first what we're going to do is we're going to find the angle opposite the other given side. So we're going to use law of sine, so we know A and A, so we've got the sine of 35 degrees divided by side A, and then we know side B, so we're going to fill in sine of B over 12 equals sine of 35 degrees over 10. To solve for B, we're going to first multiply both sides by 12. And then, since I want to undo or get rid of the sine function, we go back to our previous math classes and remember that that is sine inverse. So B is going to be sine inverse of 12 times sine of 35 degrees divided by 10. Be really careful when plugging this into your calculator. You want to make sure that you're plugging in your parentheses where they need to go. So you need to remember to close that parenthesis in particular. This is going to give us 43.50 degrees. Now here's the key to when we have 0, 1, or 2 solutions. We need to remember how sine inverse works. It's only going to give us angles that are between negative 90 degrees and positive 90 degrees. But in general, this mysterious angle that we have yet to solve, that we just tried to solve right now, B, it could be obtuse. And remember, obtuse means between 90 and 180 degrees. So this would be a quadrant 2 angle. So it's possible that B is 43.50 degrees, but it's also possible for it to be the quadrant 2 angle where its reference angle is 43.50 degrees. So if I'm in quadrant 2, I could have 180 minus that angle. So B could be 136.50 degrees also. So this is when we have two possible cases. So we're going to continue using both of those angles. So now that we have a second angle, we can easily find the third, knowing that our three angles add up to 180 degrees. So in our first case, where B was 43.50 degrees, we get that angle C is 101.50 degrees. If, however, we're in that case 2 opportunity, where B is 136.50 degrees, we get that C is 8.50 degrees. Now here's the difference between if there's one triangle or two triangles. If this C ends up being negative, we know that's not possible, and that's when there's only one triangle. But if both C's are positive, then they're both possible triangles. So we do actually have two possible triangles here. But we've got both angles, so the only thing that's left is to find that third missing side, which is side C. And again, we're going to do it for both cases. So we set up the law of sines. So side C divided by sine of angle C equals. And again, we're going to use the A's because we know those two are there. You don't want to use information you found if you don't have to. So I'm definitely not going to be using the B's here because I was given both of my A's. So always use what you found, what you were given over what you were found if possible. Okay, so again, we know the A's, so we're going to use those. So to find C, we're going to multiply both sides by sine of C. And then in this case, we're going to plug in our two different C values. So for one of them, we're going to plug in 101.5. And in the other one, we're going to plug in the 8.5. So in case 1, where C is 101.50 degrees, then side C is 17.08. In case 2, where angle C is 8.5 degrees, side C is 2.58. So what we're going to do is we're going to write down both cases separately, so case 1 and case 2. So we have all of our information. So for both of them, right, what we are given is still the same. Angle A is 35, side A is 10, side B is 12, that's what we were given. And then the rest of them change depending on if B is acute, aka less than 90, or obtuse, between 90 and 180. And this is kind of what it looks like in the two cases. So it's kind of hard to see here because the second one's a little bit more zoomed in. But this is the same for both of them. My side B, my length of side A is the same, and my angle A is the same. So in case 1, B is an acute angle, and in case 2, B is obtuse. So that's where the big difference lies. Acute and obtuse. And that obviously changes C a lot also. Okay, both side C and angle C. So that's kind of the two possibilities geometrically. So let's try another one. Given that angle B is 50 degrees, side B is 20, and side C is 15, solve the triangle. So just like in the first example, we're going to solve for the angle opposite the other given side. So we're going to solve for C first. So sine of C over 15 equals sine of 50 degrees over 20. And again, we're going to multiply both sides by 15. So we're going to bring the 15 up and then hit it with sine inverse to get rid of that sine. So C is sine inverse of 15 sine of 50 degrees divided by 20. We do that, we get that C is 35.07 degrees. And again, just be careful in your calculator, make sure you're closing off that parenthesis. So if we have a quadrant 2 angle, again, it's going to be 180 minus that what is now reference angle of 35.07. And that gives us 144.93 degrees. So at the moment, those are our two possible cases within this example. Again, our second step here is to find our third angle. So in case 1, A, our missing angle, is 180 degrees minus angle B minus our first case angle C. And we get 94.93 degrees. For case 2, we're going to subtract our 50 degrees, again our B, subtract our other C, and we get a negative. So and because of that negative angle, we know that there isn't actually a case 2, and there's only one triangle. So since there's only one triangle, I don't have to kind of do this twice. So to find our missing side, we're going to use the law of sines. So our missing side this time is side A. So side A over the only angle A that we have, because again, this guy is not an actual angle. You can't have a negative angle within a triangle. Then we have the A over sine of 94.93 degrees is 20 over sine of 50 degrees. Again, we want to use the B's because we were given both of the B's. Okay. Multiply both sides by our denominator, and we get 26.01. So I didn't mention it in the previous case, but again, you always want to check your answers to make sure they make sense. Right? So looking at our angles, A, B, and C, we know that angle A is the largest, right? It's the 94.93. And then of our sides, A is also the largest. Our angles has C, which was this guy, being the smallest, and side C, which was 15, is also the smallest side. Right, so you want to make sure your larger angle is opposite your larger side, your smaller angle is opposite your smaller side. Okay, so let's do another one. Given that angle C is 70 degrees, side A is 30, side C is 14, solve the triangle. So we're going to look at it and say, okay, the angle that I can solve for is the angle opposite the other given side. So we're going to solve for A. So we set up our law of sine. Sine of A over 30 is sine of 70 degrees over 14. To solve for it, again, we're going to multiply by 30 on each side and then hit it with sine inverse. So we get that A is sine inverse of 30 times sine of 70 degrees divided by 14. Plug this into our calculator, and we should be getting an error. It should either say error or maybe domain error, depending on your calculator. So this is what happens when there's no triangle. So if I tried to draw this triangle correctly, if I got a ruler and a protractor out, I would see that side C isn't large enough to get up to A. So side C maybe would have like ended right here if I was drawing it from B. It would be too small to actually complete this triangle. So that's kind of what it would look like geometrically. All right, so we'll do one more. Given angle C is 45 degrees, B is 120, and C is 100, solve the triangle. So again, we're going to solve for angle B because that's the angle opposite the other given side. So we set it up. Solve for angle B. Hopefully this is starting to look repetitive, right? We multiply both sides by the denominator. We hit it with sine inverse. Whoops, I forgot to put that this is 58.05 degrees. So plugging it in, we get 58.05 degrees. But again, we could have an obtuse angle, so we're going to take 180 minus the 58.05 degrees, and we get 121.95 degrees. So we've got two possibilities at the moment. We'll see in a second whether that second case is actually a possibility or not. So we're going to set up our equation. In my first case, A is going to be 180 minus 45 minus 58.05. And we get 76.95 degrees. In case 2, we'll subtract the other angle that we found, the 121.95 degrees. And that gives us a positive 13.05. So there are two possibilities here. In either case, the last thing we need to find is side A. So we'll set up law of sines with the information we were given, that 100, that 45 degrees. Again, multiply both sides by sine of A. So for each A, my 76.95, my 13.05, for each angle A, I will find its corresponding side A. So for case 1, if capital A is 76.95, then little a is 137.77. And in case 2, if we're looking at 13.05 degrees, we've got 31.93. So I'm just going to kind of put them together here. And again, you want to check, right? In case 1, my largest angle is angle A, and that is my my largest side also. My smallest angle is angle C, and side C is my smallest side. In case 2, it's different. In case 2, my largest angle is B, and my largest side is B. And now I have my smallest angle. Sorry, I got confused for a second there. My smallest angle is A, and my smallest side is A. Okay, so again, you always want to check that. And again, kind of as a visual, here's what it would look like. So here is where angle B is acute, that 58.08, and here's where it's obtuse, the 121.95. Okay, so try it out, read through the book, let me know if you have any questions. Thanks.